Hello everyone, hope you all are doing well. So in this video we'll discuss the last problem of Lead Code bi-weekly contest 112. It's a high level problem and a very good one to solve. We'll see why, because it involves the concept of modulo inverse. So okay, let's first see what the problem is asking us to do. So the problem name is count k subsequences of a string with maximum beauty. Okay, so you are given a string s and an integer k. Now a k subsequence is a subsequence of s having length k and all its characters are unique. Okay, that is every character occurs only once. Okay, let fc denote the number of times the character c occurs in x. Okay, this is the total frequency. So if I talk about the original string, so f of a will be the number of times a occurs in the original string, not in the subsequence. Okay, now the beauty of a k subsequence is the sum of fc for every character c in the subsequence, in the k subsequence. Okay, for example, suppose this is the string, right? Now how many times a is coming in this string? One time. How many times b is coming? Three times. How many times d is coming? Two times. Okay, and k is equals to 2. That means choose every subsequence of length equals to 2. Right, and every character in the subsequence should be having two distinct characters, right? For example, a b b b d d. Okay, so I have to choose two distinct characters. So what I can do, I can choose this and this, right? This is one of the ways. I can choose this guy and this guy. I can choose this guy and this guy, this a and this d. Getting it? A and d. I cannot choose two b's because the I have to choose two characters and they should be distinct, right? So English characters have 26 lowercase English characters, right? So that means I cannot form a subsequence greater than 26, because at max I can have 26 distinct characters, right? That's it. So what I mean to say, some k subsequences of S are AB is there. Now what's the beauty of AB? The number of times A is coming, that is 1, plus the number of times B is coming, that is 3. So beauty is 4. What's the beauty of AD? It's 5. 1 plus, yeah, it's 3, sorry, my bad. It's 1 plus 2. And what's the beauty of BD? It's 3 plus 2, that is 5. Okay, now what we have to do, we have to return an integer denoting the number of k subsequences whose beauty is the maximum among all the k subsequences. Since the answer may be large, return the answer modulo this value. Okay, a subsequence of a string is a new string formed from the original string by deleting some, possibly none of the characters without disturbing the relative positions of the remaining characters. Okay, notes, fc is the number of times a character c occurs in s, not a subsequence k, right? So basically that's what I told. It's frequency of a character in the original string, not in a subsequence. Okay, now two k subsequences are considered different if one is formed by an index that is not present in the other. So two k subsequences may form the same string, right? Simple basic stuff, right? Now in this case it says you have to form subsequences, right? So ultimately, you have to choose k different characters. So here also order doesn't matter. Whenever you get a question related to subsequence, just see that is the order really something that matters in that question or not, right? Now here our task is to choose k distinct characters, right? Now whatever is the order, ultimately it will form a string. Getting it? So our aim is to choose k distinct characters. Order will not matter here. Okay, now let's take this example to understand it better. So this is my string. Okay, how many times b is coming? One time. C is coming two times. A is coming one time. Great. I have to check all the k subsequences. That means subsequences having two distinct characters. Okay, so now what I can do, so also I want the maximum beauty, right? I want the maximum beauty. So just see here, c is coming two times, b is coming one time, a is coming two times. So my first preference will be that, okay, try to form subsequences which includes c, because c is having more frequency, so it will increase the beauty, right? So let's choose C, right? Now, what we can do is, with C, I need one more character. So here there are two possibilities, B and A. Now both of them have the same frequency. Both of them have the same frequency. So if I choose CB, then how many subsequences can I form using C and B? So I have two occurrences of C. I have one occurrence of B. That means I can form two different subsequences which have C and B, right? Because there are two occurrences of C and one occurrence of B. So I can pair one C with the B, and then in the second subsequence I can choose the other C and combine it with the B, right? Now what was the other possibility? You can combine C with A. Again here you have two occurrences of C and one occurrence of A, so again two. So these both have the same beauty, right? This guy has a beauty of 3, this guy also has a beauty of 3. So what we have to do, we have to return the number of subsequences that I have with the maximum beauty. So here maximum beauty itself will be 3, so there are 4 subsequences, 2 with CA and 2 with CB, BCV, BC, whatever you call it. So ultimately your answer is 4, and hence your answer is 4. Just see the explanation, right? From S we have A occurring one time, B occurring one time, C occurring two times. Now the K subsequences of S are, just see all the subsequences they have formed. So you form BC, it gives you 3. You again form BC, it gives you 3. You form BA, it gives you 2. You form CA and then CA. Getting it? So your answer is 4 because there 4 of the subsequence have beauty 4. Let's take one more example. This one is A, B, B, C, D. Now how many times A is coming? One time. B is coming 2 times. C is coming 1 time. D is coming 1 time. What I want the length to be 4. Right? I want the length to be 4. So again, 4 distinct characters needs to be chosen. And in this case, what happens? I have 4 distinct character itself, right? So what I'll do? I'll choose all of them. But how many possibilities are there? How many possibilities are there? Look, I have only one occurrence of A. I have 2 occurrences of B. I have 1 occurrence of C and 1 occurrence of D. So that means there will be only 2 possible subsequences that will be formed, right? Because A has only one option, C has only one option, D has only one option, but B has 2 options. So suppose these are the 2 options. So first I can pair this one in the subsequence, and then I can pair this one. So ultimately I'll have 2 subsequences, and hence my answer is 2, right? I hope the problem statement is clear. Now the constraints are the length of the string can be this one, a large one. K will always obviously be less than S dot length, and S consists only of lowercase English characters, right? Now let's go into some observations, right? If the problem statement is clear, I would highly encourage you pause the video and try to attempt it yourself. Otherwise you can come back to the solution, right, to proceed further with me, right? So the first thing, this is K. So K is the number of distinct characters I need in a subsequence, right? Now S consists only of lowercase English characters. So obviously whenever K is greater than 26, it's not possible, right? You have only A to Z in your string. Now how can you form a subsequences having more than 26 distinct characters? So whenever K is greater than 26, answer is not possible. First thing. Second thing, suppose in my string I have A, D and E. That means I have 3 distinct characters. But the question is saying you form a subsequence which has more than 3 distinct characters. Then also your answer is 0. Because you have X number of distinct characters and someone is asking you to form a subsequence which has more than X distinct characters. That is not possible, right? So you return false in that case also, right? Basic stuff. These are the boundary conditions, right? Now comes the question, what happens in generic cases? These were the edge cases, right? Now what happens in the generic case, right? Now I want my beauty to be maximized, right? I have to find the subsequences which have the maximum beauty. But in that case, first I have to find out what is the maximum beauty, right? So suppose there are some characters. Now each character will have certain frequency. Let's suppose a character has a frequency 5, 6, 2, 1, 3, something like this, right? Let's name it A, B, C, D, E. Okay. Now, and I want to form a subsequence of length k equals to 3. Just taking basic example, right? Now just see, I want the beauty to be maximized, right? I want the beauty to be maximized. So, okay, let me do it like this. Let me do it like this. There is a large string, okay? In that string, A is coming 5 times, something like this, okay? Let me make it more clear. B is coming 6 times, this is coming 2 times, 1 times and 3 times, something like this, okay? So in the original string, the frequency of A is 5, B is 6, C is 2, D is 1 and E is 3. I want to form 3 character subsequences, means having 3 distinct characters, okay? And my aim is to maximize the beauty. First I need to find the maximum beauty, then I need to find all the subsequences having that maximum beauty, right? Now if you just sort it, what it becomes? B, A, E, C, D. This guy comes 6 times, this comes 5 times, this comes 3 times, this comes 2 times, this comes 1 time, right? Now I have to choose 3 distinct characters. Now just see, my friends, this, if you choose these three, what is the beauty? Right, if you choose these three, I'm not talking about which occurrence of B you choose, but ultimately if you choose these three, your beauty will be 6 plus 5 plus 3. Right, suppose you make BAE, what happens? This is occurring 6 times, 5 times, and this time, so this is 14. No, this is the maximum beauty you can get. Right, this is the maximum beauty you can get. Now comes the question, how many subsequences are there which has this beauty? Right, how many subsequences are there? Just see this one. So I have 6 instances of B, so I can choose any one of them. Right, I can choose any one of them. I can choose any occurrence of B. Right, into I have 5 occurrences of A, I can choose any one occurrence of A, so this is 5. Into I can choose any occurrence of E, so this one. So 6 5 is 30, 33 is 90, so I can form 90 subsequences which have maximum beauty. Remember, I want distinct characters, so I need 3 distinct characters. It's not like that you choose 3 occurrences of B. No. Getting it? This is what it looks like, right? This is again a generic case. Okay, this is again a generic case. Now let's take some tricky cases where the question becomes complex and a good one, right? Let's take some tricky cases. So suppose I have to form a four letter subsequence, right? I have A, B, C, D, E, F. So what happens? A occurs, I'm just writing it in sorted order, right? It occurs 5 times, this occurs 4 times, these occurs 2 times each. Right, these occurs 2 times each. Now first thing is finding the maximum beauty. So I have to choose 4 distinct characters. Now this is obvious that I'll choose A. Great. Also I'll choose B. Awesome, you choose these 2. Now out of 6 possible characters, you have chosen 2 distinct characters, right? So you have to choose 2 more distinct characters. But what happens here is, I want to choose 2 characters, but I am left with 4 characters and all of them have the same frequency. All of them have the same frequency, right? So what I mean to say, you can choose A, B, C, D also you can choose, right? C, E, C, F, D, E, E, F, anything is possible, right? What I mean to say, everyone has the same frequency. You can choose any 2 distinct characters out of these 4 and ultimately the beauty will be same, but the subsequences that you form is different. So you need to take care of this thing, right? So let's talk about basic mathematics, right? Forget about how to write the code. Basic mathematics. I need to choose 4 characters. I have chosen 2 characters. Great. I am left with 4 characters. Out of these 4 characters, I need to choose 2 more characters. 4C2. Simple. 4C2 is something I can do, right? So this is what I need to calculate. This is what I need to calculate, that out of 4 characters, I need to choose 2 characters, right? And once you choose it, what will be the contribution of those 2 characters? So the frequency of first character will also be 2. The frequency of the second character will also be 2. So what I mean to say, it's 2 into 2 into 4C2. Okay. So overall, what will be the number of subsequences? 5 occurrences of A into 4 occurrences of B into 2 occurrences of one character. I am choosing 2 characters and 2 occurrences of the second character. But how many possibilities are there to choose these 2? It is 4C2. Getting it? This is what your answer is. And obviously this whole value, take mod. Simple, right? This is what you need to do. Now take a pen and paper, try to digest it, because I totally understand it's too much of a mathematical thing, right? So that's why. Now if I can simplify it for you, let's break it like this. 5 into 4 was confirmed, right? Now 4C2 is the number of combinations you can make. What is 4C2? So 4 factorial is 24, right? 6 4 24, yes. And then this is 2 into 2, that comes out to be 6. So 6 possible combinations are there. What are those 6 combinations? CD, CE, CF, right? 1 2 3, then DE, EF, 1 2 3 4 5. Okay, I am missing something, just a second, or maybe I've done some mistake. So this is CD, CE, CF, DE, DF, and then EF. Yeah, I was missing this one, right? So these are the 6 possible combinations you can make, right? So what you do, either you do like this, that I take AB and then I take CD. Now how many subsequences of this can be formed? It is 5 into 4 into 2 into 2, because 2 occurrences of C, 2 occurrences of D. Great. Then you can form A, B, C, E. This also comes out to be 5 into 4 into 2 into 2. Then A, B, C, F, A, B, what do you call it? A, B, D, E, A, B, D, F, A, B, E, F. Everyone will have the same value. So I can do it like this, right? I can do it like this, that it is 5 into 4 into 2 into 2, right? Now how many times is it is coming? 6 times. Why? Because out of 4 I am choosing any two thing. Now I hope this is clear. I have just broken it, right? 5 into 4 into 2 into 2, this comes 6 times, because there are 6 combinations, and number of combinations can be derived from this combination formula, right? So this is what you need to calculate. So that's the solution, right? That is the solution. This is what you need. Now all we are left with, how to code it, right? Now coding it is a little bit, I would say, cumbersome if you are doing it for the first time. Reason being, you need to take care of inverse modulo. Why you need to take care of inverse modulo, I'll let you know. Or rather, what is inverse modulo, I'll just let you know, or let me tell you. Okay, so suppose I have to find A mod B, A mod M. I can simply do it, right? If I have to find A raised to B mod M, I can do this as well, right? Simple. A raised to B. So you do A mod M, then multiply B, then again take mod M. Simple. I'm just telling you simple way. But if I have to do A divided by B mod M, getting it? Then this is tricky. This is tricky. A divided by B mod M, this is tricky. So you write it A mod M into B inverse mod M. Getting it? This is how you write. So I'll not go into too much of details what is Fermat theorem and all, but roughly if I talk about that, how to calculate this thing, right? You want to calculate its value, this can be calculated using this thing, that find A mod M into B inverse mod M. Now how to calculate it? This can be done using Fermat theorem. What is Fermat theorem? Fermat theorem is something like this, right? Again, if you're doing it for the first time, it may be overwhelming. Don't worry, take some time. It's a hard problem. It will take some time, so no need to worry. Okay, so it says that A raised to P minus 1 is something like this. Okay, this is what Fermat theorem is. Now P is a prime number. the number with which you take the mod. In this case, it's 10 raised to power 9 plus 7, and in this case it is mod only, right? So how do you calculate A inverse mod P? I'm just telling you what you do. You multiply on both the sides with A inverse. So this becomes A P minus 2, A inverse mod P. So if I am taking mod with a prime number and I want to I want to find the inverse of a number with respect to a prime number. So this can be done using this one. That what you do, you find the P minus 2th power of that number. Simple. This is what we need to do, and this is what Fermat theorem is, right? This is what Fermat theorem is. If you have seeing it for the first time, no worries. If the logic is clear, this becomes crystal clear. Okay, I'll just go through the solution once so that we are on the same page. But I hope the logic is clear, right? So just see what we are doing. This is the main function. If k greater than 26, that's what I told you. You just return 0. Then what you do, you find the frequency of all the characters. Okay, sort it. Okay, sort it. Now what you do after sorting, what did I say? You pick the largest k values because you want the maximum beauty, right? So initialize your variable with 1. Now I'm taking two variables, required and total present. Why I'm taking? Because in the above example I showed that there were 4 characters having frequency 2, but I needed only two of them, right? So I had 4, I wanted 2. So this is what I have total present, and this is what is required. So that's what I'm doing. So I goes from 0 to k because I need k characters. Result into equals to frequency of 25 minus e. Why I am doing it? Because I have sorted the frequency array. So it looks something like this, that the characters, the frequencies are sorted in increasing order. So it will be 1, 2, 6, 8, 10, right? I want to pick the maximum frequency first. So I'm doing 25 minus I. So this will be picked first, then this, and so on. Okay, that's why I'm doing it. So you multiply that in result, take the mod. Now I need to calculate how many of them is required, right? So what I do, if frequency of 25 minus I, that means the current character that I'm assuming, if that the frequency of that character is equals to the kth character, right? I need k characters. Okay, so just see like this. This is the sorted array. Okay, for me this is the first character, I mean the first frequency that I'm considering. This is the second frequency, third frequency, fourth frequency. So the last one that I'll pick is the kth frequency. Getting it? I need k characters. So to find the first frequency, what we did 25 minus 0 to find the, because indexing starts from 0, right? So the index for this will be k minus 1. So that's why we are doing 25 minus k minus 1. Getting it? So if the last character that I want to pick, the kth character, obviously that will be 25 minus k minus 1 from the ending, right? If these two are equal, that means required plus plus, meaning these are the top k characters I need. Out of these characters, look, this is the last character ideally that I need. Okay, now how many characters are there which are needed and which have the same frequency like this? So suppose there are 3 characters like this. Okay, so that means whatever is the number of characters having the same frequency, out of those I only need 3 of them. Getting it? So that is why required is this. Now comes the question, how many are present? So for I traverses over the frequency array. If this current frequency is equals to the frequency of one character, total present is this, right? So till now we have calculated all the metadata. Now what I need to do, out of total present characters, find the required characters. Just see one more thing here, I have multiplied the frequency of all the k characters. I showed you na that 5 into 4 into 2 into 2 into 4c2. So till here I have calculated, I just need to calculate 4c2. Okay, till here I have my answer. I've taken mod of my answer, right? Now this function will tell me 4c2 wala thing, that total present. I need to select required number of characters from total present. Okay, then I take mod and return the answer. This is the beauty, right? Choose function is the beauty, right? Out of this I want to choose this. So that means nck I want to calculate. Now what is n? This is n factorial divided by n minus k factorial into k factorial. This is what I need to calculate. So just see, that is what I am doing here. Result is 1. I goes from 1 to n. Multiply it, right? What is n factorial? 1 into 2 into 3 up till n, right? Multiply it and take mod. Simple, right? Now I need to calculate k factorial, but k factorial is in denominator. So how do I calculate it? I calculate it like this, right? K factorial inverse mod 10 raised to power 9 plus 7. That is what I need to calculate, right? As I showed you. Now how can I calculate it? I can calculate it using, just a second, using Fermat theorem. This is acting as a, so this will be k factorial p minus 2. Getting it? This is what I'll do. So result equals to inverse modulo of 1, right? Inverse modulo of 1. So in short, what I'm doing now, what is k factorial? 1 into 2 into 3 into up till k. So for all these values, just keep on calculating power minus 2 and just see, that's what I'm doing. You pass a number, right? Where is it? Inverse, yeah, this one, sorry, this is the one. This is Fermat theorem. That number power mod minus 2. What is mod? This is the prime number, right? That is what we do. Just pass it, and we all know how to calculate a raised to b mod m, right? Getting it? This is a basic function, right? We all know how to calculate a raised to b mod m, but what power to calculate? That is a given number raise mod minus 2. Getting it? So we do it for all the numbers, right? 1 2 3 4 up till k. Great. So till now what I have, till this point, what do I have? I have n factorial divided by k factorial mod m I have. Now what else I need to do? This also I need to include in my results, right? So I goes from 1 to n minus k. Again do the same thing. Modulo inverse of I. Getting it? Again the same function will be called. So ultimately at this point, what you'll have after you come out of the loop, you'll have this, my friend. You'll have this. You'll have n factorial divided by k factorial n minus k factorial mod m. This is what you need and this is what you'll have. And ultimately you just return that result. Getting it? This is the beauty. And I would say knowing Fermat theorem is the main thing. I just showed you the derivation. Again, I'll show you the derivation. Derivation is something like this, that this is the Fermat theorem. Okay. Mod p, take inverse at both the sides. So this becomes mod m, mod p, whatever you call it, Okay, getting it? Mod p, and here it becomes A inverse mod p. So to calculate inverse of a number with respect to a prime number, you calculate p minus 2th power of that number, and that is what we are doing. We are calculating p minus 2th power of that number. Okay, and we are keep on multiplying it. Simple. Finally, you multiply it and you return the answer, right? I'll just reiterate. If you are seeing modulo inverse for the first time, don't worry, you just need to go through any of the resources of modulo inverse and this will become crystal clear. I've tried to explain it briefly because I don't want to make this video very long, but this is how you solve this problem. I hope logic wise, mathematically this is clear. It's all about how you write the code and implementation is always very easy. Coming up with the logic is the main part, right? So yeah, that's it what I have for the solution. I hope you learned something new from this video. So please do support it by giving up a thumbs up. Do subscribe to the channel as well. In case you have any queries related to the solution, mention that in the comment section. I'll try to revert on each one of them. Thank you. Take care. Bye bye.